In section 5.2, problem number 33, we need to find sine of alpha plus beta and tangent of alpha plus beta given this information. So cosine of alpha is negative 7/25, and it ends in quadrant 2. Cotangent of beta is 15/8 with that terminal side in Q3. So first of all, let's look at our formulas that we got from the identities for sine of alpha plus beta and tangent of alpha plus beta. So let's recap on that. So for sine of alpha plus beta, we have sine of alpha and alternating functions for beta, same sign plus, and then alternate function, that's our formula for sine. And for the tangent sum, our formula is the same sign in the numerator and opposite sign in the denominator. Okay, so what we have so far, from what we need, we have cosine of alpha and we have cotangent of beta, which we don't directly need. So we do need to find all these other pieces: sine, cosine, sine of alpha, cosine of beta, and sine of beta, tangent of alpha, and tangent of beta. So we got to use these quadrants to help us build the triangles and find the missing pieces. So let's look at alpha first. So for alpha, it ends in quadrant 2, so the triangle will be oriented this way. So my y is positive, my x is negative, so I'm going to have a negative cosine, which I do because they've already given me cosine, and a positive sine. And cosine of alpha, here's my little reference angle, is, so cos, so that's adjacent over hypotenuse. So I gotta find this guy right here. And I can use the Pythagorean theorem, so that's a -7. So -7 squared plus that other side squared gives me the hypotenuse squared. So when I solve for b, I get the square root of 25 squared minus -7 squared. And if I put that into my calculator, I find that that third side is 24. So now I can find everything I need about alpha. So now I can see that, let's see, I already have cosine of alpha equals -7/25, but I'll go ahead and copy it down so I have it. And I now have, let's see, yeah, sine of alpha equals 24/25. That's positive. And we can also see tangent of alpha is the opposite over adjacent, which is -24/7. Now let's do that same process for beta. So I'll do a different triangle for beta. So let's do beta in, oh, I don't know, blue. Let's do blue. So my triangle for beta is in that third terminal. So it's, I'm sorry, quadrant. So it's oriented this way with, oops, sorry. No, that's not right. Sorry, like this. With that, there's my reference angle. And let's see, I'm given the cotangent of beta is 15/8. So cotangent, that's the inverse of tangent. Tangent is opposite over adjacent. So cotangent is going to be adjacent over opposite. So that's 15/8. Then I can find the hypotenuse with the Pythagorean theorem. So 8 squared plus 15 squared gives me that hypotenuse. So if I solve for the hypotenuse, I get square root of, and these are both negative, 8 squared plus 15 squared, which equals 17. All right, so now I can find everything I need about beta. So let's see. So cosine of beta is adjacent over hypotenuse, so that's negative 15/7. And sine of beta is negative, 17ths, 8/17. And tangent of beta is opposite over adjacent, so that's negative 8 over negative 15, so it turns out to be positive. Okay, so now I have all the raw data that I need from those triangles to fill in those formulas. So I'm going to put those triangles aside and focus back on this purple part A. So it's really just plug and check at this point. So sine of alpha plus beta equals sine of alpha, which was 24/25, and cosine of beta, which is over here, which is negative 15/17, plus cosine of alpha, which is negative 7/25, times sine of beta, which is negative 8/17. When I multiply those together, I get, let's see, for the denominator of both of these, I'll get a 425. 25 times 17 gives me 425. And in the numerator of the first part, I get 24 times negative 15, which gives me a negative 360. And plus 7 times 8, negative 7 times negative 8 gives me a positive 56. And I add those together and I get negative 304 over 425. So sine of alpha plus beta equals negative 304 out of 425. Okay, for part B, I needed to find tangent, so now I'm going to use these. Let's see, let me change colors here. These two guys, and I'm going to add them together in the numerator and multiply them together in the denominator. So I'm going to scroll down a little just to make some space for that. So tangent of alpha plus beta equals tangent of alpha, which is negative 24/7, plus tangent of beta, which is 8/15, all over 1 minus tangent of alpha, negative 24/7, times tangent of beta, which is 8/15. This gets a little messier, so I'm going to scroll down and make some space here for some messy math. And I find okay, so I need to add the fractions in the numerator. When I add 24/7 and 8/15 together, I need a common denominator. So I'm going to use that A over B plus C over D equals AD plus BC over BD formula to add those two fractions together. And I'm left with here, in the numerator anyway, let's see, 7 times 15 in the denominator of the numerator, and negative 24 times 15 plus 8 times 7, That's in the numerator of the big fraction. In the denominator, I'm adding, let's see, 1 minus this product here. So that I'm just going to, okay, so let's see, 1 minus 7 times 15, which is 105. So I'm going to go ahead and change that 1 to a 105 over 105, so I have a common denominator so I can subtract. And then negative 24 times 8 gives me negative 192. Okay, I'm taking this another step. Okay, so looking at the numerator again. 7 times 15 we said is 105. And negative 24 times 15 is negative 360. 8 times 7 is 56. And then a big fraction bar, that's the whole numerator. And then 105 over 105, or 1, minus 192 over 105 is plus, because it's minus a negative. So I get plus 297 over 105. Now notice I have common denominators. In the numerator and denominator, I have this common 105 here. So those 105s will cancel when I flip the second and multiply. And I'm left with negative 360 plus 56 gives me negative 304 over 297. So that's my final answer for tangent of alpha plus beta is negative 304 over 297.